Good morning, my YouTube viewers. It's Crystal here. I'm just making another video. I'm going to have to try to keep the video short because my recorder on my computer is not working, and it's because the Xbox app isn't working. And as a result, I'm having to use the free online screen recorders. So that's what I'm doing. And basically, I'm doing the disaster tweets on Kaggle, and I'm using Keras bidirectional LSTM model to do that. And so what I did yesterday is I tried to use that model to make predictions, and I got a 70% accuracy on that. In the past, whenever I very first started using natural language processing, I would use sklearn because sklearn had some natural language processing functionality, but I decided I wanted to use Keras. Keras is, or Tensorflow Keras. Tensorflow, my best score was only 70%, so I need to see if I can try to improve the score and get the score up to about 75%, which is what I had when I was using sklearn. But TensorFlow is like the up and coming library, and it has lots of functionality. So that's what we're going to do is TensorFlow. So I'm using Kaggle's disaster tweets. We've got our competition description where you want to classify a disaster as being an emergency or not, or classify a tweet as being a disaster or not. And then we're going to go ahead and import the libraries that we're going to be using, which is going to be pandas, numpy, os, re, string, collections, counter, time. So pandas and numpy are the two classic libraries that we use when we're working with machine learning. OS goes into the operating system. RE is to do with text and characters. A string is to do with text and characters. Counter collections is to count words. Time is to check the amount of time that it takes to do something. Then we're going to import text block. That's from natural language processing. We're going to import NLTK, which is natural language toolkit. And then we're going to import TensorFlow, and that gives us our deep learning functionality that helps us to do our natural language processing. Then we're going to import sklearn, which gives us our machine learning processing. We're going to import matplotlib and seaborn as visualization. So we import all these packages, and we're using version 2.11 on TensorFlow. So we're going to load our CSV files up using the OS, and then we're going to find we've got three files. One is train, the second is test, and the third is submission, what Kaggle wants to see when we submit our work. So we're going to use pandas to read our files, and we're going to convert those files to three different data frames, being train, test, and submission. I decided I was going to set the seed on TensorFlow to try to make my predictions more reliable. I'm analyzing the target, and you can see that there's a mild class imbalance, like more non-disasters than disasters. We do a value counts on the target, so you can see how many are zeros and how many are one. So I'm assuming that zero is not a disaster. Now we set up tweets is train text, and target is train target, and tweets test is test text. Now we're going to process the text, which we're with natural language toolkit. And so we're going to convert all the tweets to lowercase. We're going to replace a at mark with a space. We're going to replace a hash mark with a space. We're going to join up all the words, and then we're going to limitize the words. So you can see that then what we're going to do is we're going to clean the tweets and clean the tweets test. And now what we're going to do is we're going to count the words, how many unique words, and you can see that there's 26,005 unique words. And then now what we're going to do is we're going to set some parameters. So batch size is 32, num training examples is train.shape 0, train split is 0.8, val split is 0.2, training size is int, num training examples times train split, steps per epoch is int, num training examples times train split, and then it's going to floor the batch size. And auto equals TF, auto experimental autoamine. So we're going to set our training sentences and our training labels. We're going to set our valid sentences and our valid labels, and we're going to set our test sentences. And we're going to print that out. And so we're going to see how many we have for training, validation, and test. Now what we're going to do is we're going to tune our hyperparameters. Max words is going to be 10,000. Max length is going to be 100. Embedding dimension equals 100. LSTM units equals 64. And num classes is going to be the length, set, targ, and it's 2 in this instance. So we're going to do a def token test. And so tokenizer equals tokenizer num words equals max words, tokenizer.fit on text tweets, sequences equals tokenizer.test the sequences tweets, and then it's going to return the sequences, and then we're going to pad x and x test to make sure that they're all the same length, and then we set our target. And then so we do some more hyperparameter tuning, vocab size equals len counter, embedding dim equals 32, max len equals 20, trunk type equals post, padding type equals post, OOV talk equals XXX, and sequence length. So here it says embedding dim 32, and we had another, embedding dim of, I think it was 64. But here it says embedding dim 32. And that says embedding dim 100. Dimension of word embedding. So I've got 2 embedding dims, which perhaps I need to look at because I don't need that. So I've got one that says 100 and one that says embedding dim, dimension of word embeddings. So that's something I can look at. So I've got 2 embedding dims. Okay, so now what we're doing is we're just checking the shape of training sequences, valid sequences, training labels, valid labels, and test sequences. Now we're going to tokenize everything. And then with the word index, so tokenizer equals tokenizer, num words, vocab size, and then token, and then tokenizer fit on text training sentences, and then word index equals tokenizer word index. So training sequences equals tokenizer dot text to sequences, training sequences, training padded equals padded sequences, training sequences, max len equals max length, padding equals padding type, truncating equals trunk type. And then we print the training sequences for 10 and the training sentences for 10. And you can see that I did the padding for valid sequences and I did the padding for test sequences, but it wouldn't work when I said print training sequences, training sentences. It didn't work on valid or test. So I had to leave that blank. Now we define our model. which is a sequential by LSTM. So you've got your vocab size, and then you've got your embedding dim, and you've got your length. So here we're going to have a little problem, which I'm going to have to look at, because I've got two embedding dims. I've got one embedding dim of 100 and one embedding dim of 32. So I'll have to go back and delete one of the embedding dims and see if that will improve my score. And then we have a layer, which is our bidirectional LSTM, and it's going to be 64. And then we have a dense layers of 32, which is ReLU, and a dense layer of 1, which is sigmoid, and this is a binary classification. And then we compile the data into the model using OLAS as binary cross entropy, optimizer as atom, and metrics as accuracy. So we do a summary. And now what we're going to do is we're going to train the data into the model for 30 epochs. And we could use more epochs if we wanted, but the more epochs you use, the longer it's going to take to do it. So I just did it 30 epochs in this instance. So we evaluate the model, has 68% accuracy, and then what I did was I created a graph so you can see the accuracy and the loss, and you can see the loss is pretty up and down. We're going to make predictions on the validation set, and then we're going to analyze it and see what the predictions are. And in this particular one, you had more disasters than not. So we check our accuracy, 68%. We put it on a confusion matrix. So you can look at the confusion matrix, see how that's working. And then we put the actual and the predicted values on a data frame. And now we're going to predict on the test set. And then pred equals model.predict test padded is greater than 0.5 as type int 32. And then we're going to analyze the predictions, and you can see that it's almost balanced. And we couldn't put it on an accuracy or confusion matrix because we don't have the actual values. And then so what we do is we prepare our submission and we submit it to Kaggle, and this is what we submitted to Kaggle. And there you go. Our best score was 70%. But as I do the code review, I do think that I need to change the embedding dim and see if that improves my score. So thank you so much for watching this video. I have to keep it short because I'm using an online video recorder because my video recorder on my laptop no longer works. And if you like my video, please like, subscribe, and share. And I look forward to communicating with you in the next video.